Welcome to SCS Engineer's series of mini webinars focused on carbon sequestration and deep well injection. In today's presentation, we're listing some considerations when assessing the feasibility of carbon dioxide storage. Ms. Casey Garber will talk about the economics of storage and some federal funding options that may be available to you, regulatory considerations at both the federal and state levels, geologic considerations for properly siting a carbon dioxide storage well, and Casey will also talk about what to do if on-site storage is not feasible. Casey Garber is a geologist with the SES team located in central Illinois. Her expertise lies in geologic site characterization, delineation of areas of review, and development of testing and monitoring plans for carbon capture and storage projects. Over to you, Casey.
Thank you, Stephanie. I appreciate the introduction. So I'd like to start this webinar by discussing why it's a good idea to conduct a feasibility study before fully pursuing a CO2 storage or carbon sequestration project. For one, these projects are a long-term commitment of typically at least 70 years, and there are significant technical, regulatory, and financial complexities to consider before making this commitment. When assessing feasibility, it's important to keep in mind that deep well injection for the purposes of geologic sequestration of CO2 is not possible everywhere. Additionally, regulatory requirements are variable and dependent on location, so you'll want to form a solid understanding of the regulatory space before pursuing the application process. Also, the financial impact of one of these projects is not linear with time. Rather, it will be variable based on what phase the project is in. And ultimately, you will need to consider the financial impacts and whether or not a sequestration project will be viable over both the short and the long term. So let's talk about some of the financial considerations first. There are several federal funding options available for these carbon storage projects in the form of credits that can be stacked, including the 45Q tax credits available through the Bipartisan Infrastructure Law or the Low Carbon Fuel Standard credits, and also in the form of a grant through the U.S. Department of Energy's Carbon Safe program. There are some caveats to the federal funding, though. For one, the tax credits do not come into play until you actually start injecting carbon dioxide. It can be months to even a few years following the application process that you receive your permit to inject. Additionally, the carbon safe grants are open for application during specific timeframes and involve a lengthy review process. As I mentioned on the last slide, the spend rates for these projects are not linear with time, and it is important to remember that there will be significant upfront capital expenditure early in the project in terms of the permitting and site characterization process, and the injection well and monitoring network construction process. Ultimately, the overall costs will depend on the outcome of your feasibility study and how complex the sequestration project would turn out to be. What are some of the regulatory and other relevant considerations to evaluate during the feasibility study? For one, you'll need to understand who has primacy, which is the responsibility for implementing an approved regulatory program over Class 6 underground injection control. In most cases, this is at the federal level with the corresponding US EPA region or Environmental Protection Agency. At this time that I'm giving this webinar, the state agencies only in Wyoming and North Dakota currently have primacy for Class 6 injection, but there are several other states in the process of applying for primacy or considering applying. Next, you should develop an understanding of how mature the regulatory framework is for the entity that does have primacy. This can be accomplished by reviewing the respective underground injection control programs, as well as having preliminary conversations with the regulatory agencies. You will also need to assess whether any state, county, or other local regulations prohibit Class 6 injection wells. And it's important to consider the concept of pore space ownership at this stage too. Typically, the surface owner of a plot of land is also considered the owner of the pore space beneath, with some exceptions. However, in many states, the concept of pore space ownership is unclear or undecided at this stage. Also, you'll need to start to consider any restrictions on the size of your project and whether or not you may need to enter into agreements with adjacent landowners. If the regulatory evaluation finds that Class 6 injection is prohibited at the state level or on a more local level that affects your project area, you will need to consider off-site sequestration options, which I'll discuss in a little bit more detail later on. If there were no red flags uncovered during the regulatory evaluation, you can proceed to conducting a preliminary evaluation of your site's geology. You're most likely to find ideal geology in sedimentary basins and other areas that have been previously utilized for oil and gas exploration, as well as areas where other injection well classes, such as class 1 or 2 for disposal, have succeeded in the past. I use Illinois, and more specifically the Illinois Basin, as an example of where there are large areas that are considered to be likely geologically feasible for carbon sequestration, as shown in green on the map to the right. The Illinois Basin has the benefit of being previously and currently utilized for oil and gas exploration and production, as well as successfully hosting other injection wells. And in fact, the first fully developed and implemented Class 6 injection project in the US, the Illinois Basin Decatur Project, is hosted in the Illinois Basin. When you're assessing geologic feasibility, you'll need to evaluate whether potentially suitable injection intervals and confining or sealing intervals exist at the appropriate depths, whether there are large faults or other large-scale geologic structures that could threaten or enhance permanent CO2 storage, and whether aquifers and underground sources of drinking water are positioned relative to a potential CO2 storage complex. This is also a good time to estimate how much site characterization work will be required in the permitting process to show that a site is indeed suitable for sequestration. So what if it turns out that on-site sequestration is not going to be feasible at a given location? Unfortunately, this is a possibility, given that geology will not be ideal everywhere, and there may be some concerns with pore space ownership or regulations that deter or even prohibit Class 6 injection. The upshot to that, however, is that there are off-site sequestration options that you can consider. The off-site options would involve transportation from your facility via pipeline, railroad, truck, or barge to some off-site location where the CO2 will be injected. This location may be other company-owned property where Class 6 injection is likely to be feasible, some sort of carbon storage hub, which could be either privately owned by a separate company or developed as a centralized location in the case that you have multiple company facilities. This could also be on public land for which you obtain a lease agreement, such as through the Bureau of Land Management, or on leased private land where you would enter an agreement with the property and pore space owner. While there are many options available for off-site sequestration, the options that are available to you will be strongly dependent on the location of your facility, where you're capturing the carbon dioxide for sequestration. I'd like to close out this webinar by tying things together into some recommendations. When assessing feasibility for carbon sequestration, you should first consider the financial impacts by keeping in mind that there are variable spend rates throughout the life of the project, including significant upfront capital expenditure and long-term operating expenditure. You will need to assess whether there are any red flags with the regulatory framework or pore space ownership in your particular location. Then you'll need to assess whether the site-specific geology is suitable or likely to be suitable for sequestration. And again, it's important to note that if fatal flaws are uncovered in this process, there may be off-site sequestration options available to you. This may increase the overall complexity of the project and the amount of assessment for feasibility that needs to be done early on. However, you can weigh each of the available options for the advantages and disadvantages, how much risk the various options may incur for each of the assessed feasibility criteria versus how much risk you're willing to take on, and how your project may ultimately be impacted. I'd like to thank you very much for your time and attention, and I'll now turn it back to Stephanie for some closing remarks. Thank you.
Thanks, Casey. That was a great overview of assessing feasibility of a carbon storage project. Casey and others on the SES team have presented numerous topics in this mini webinar series. Please check those out and stay tuned for more upcoming topics that we're developing to address carbon sequestration and deep well injection. In the meantime, please feel free to reach out to Casey or to me for some more information, or scan the QR code on this slide to learn more about how we can help you. On behalf of the entire SCS carbon sequestration and deep well injection team, we thank you for tuning in today.